Somewhere out past the edge of what we thought was possible, there's an object the size of our entire solar system pumping out 100 billion times more energy than any star has any right to produce. Scientists are calling it a black hole star, and it might explain a mystery that's been staring at us from thousands of Hubble and Webb images for years. At the same time, there's a galaxy out there that's already fully grown, fully mature, packed with heavy elements, and it existed when the universe was only 2% of its current age. Standard cosmology says none of this should be possible this early. And yet, here it is. Let's get into it. All right, so first, let's talk about this black hole star, because the name alone sounds like something out of a bad sci-fi movie. But it's real, and it's got some of the top astrophysicists in the world scratching their heads. Here's the setup. For years now, ever since NASA's James Webb Space Telescope started snapping pictures of deep space, researchers kept noticing these tiny, super red dots showing up over and over again in almost every deep field image. Nobody knew what they were. Some thought they were baby galaxies. Some thought they were dusty stars. Nobody had a solid answer. They just called them little red dots and moved on, because there was nothing else to call them. Then a team led by a researcher named Rohan Naidu found one of these red dots that was too weird to ignore. They pointed Webb right at it and started digging. And what they found was strange enough to make headlines. Picture something roughly the size of our whole solar system. So imagine a ball that stretches out to about where Pluto orbits. Now, normally, if you saw something that size glowing, that bright, you'd assume it's a star. A big one, sure, but a star. Except this thing is putting out 100 billion times more energy than the most powerful star we know of could ever produce. That's not a typo. 100 billion times. You can't get numbers like that from nuclear fusion, which is the engine that powers every single star, including our own sun. Fusion has a ceiling. It can only push out so much energy before the physics just doesn't work anymore, so whatever's making this thing glow, it's not fusion. The team ran the numbers and landed on the only explanation that actually fit. A black hole sitting at the center of a massive cloud of gas, roughly 100,000 times the mass of our sun. That black hole isn't burning fuel like a star does, it's ripping apart and consuming the gas cloud around it. And that process is throwing off an insane amount of energy. Basically, imagine a monster black hole wrapped in a thick blanket of gas that's lit up like a light bulb, because the black hole underneath is tearing it to shreds. From far away, it looks like a giant star. Up close, it's something we've genuinely never confirmed before a hybrid. Half star, half black hole engine. They named it MOM-BH, star-1 MOM stands for the study it came out of, called Mirage or Miracle. And here's why this matters way beyond just being a cool discovery. This could be the answer to those little red dots that have been showing up all over Webb's images. If every one of those little red dots is actually one of these black hole stars, that solves two problems at once. First, it tells us what these mysterious objects actually are. And second, and this is the bigger one, it might finally explain something that's bothered astronomers for a while. How in the world do we already see black holes out there with the mass of 1 billion suns, so early in the universe's history? If black holes can grow this fast by wrapping themselves in gas and feeding non-stop, that gives us a mechanism, a believable one. But this black hole star wasn't the only oddball this same research team stumbled onto, because buried in that same survey was something even harder to explain. So here's where it gets even stranger. Around the same time, researchers were chasing down that black hole star, a completely separate team using Webb's NIRSpec instrument. Think of it like a prism that breaks starlight down into its individual colors, so scientists can measure exactly how old and how far away something is locked onto a galaxy, called JADES-GS-Z14-0. Now stick with me here, because the numbers on this one are almost hard to wrap your head around. This galaxy's light took so long to reach us that we're seeing it exactly as it looked less than 300 million years after the Big Bang. To put that in terms that make sense, if the entire 13.8 billion year history of the universe was squeezed into one calendar year, this galaxy showed up around January 7th. We didn't get here, modern humans, until the very last few minutes of December 31st. Here's the problem. At that point in cosmic history, the universe was supposed to still be in its awkward toddler years. Just clouds of hydrogen and helium slowly clumping together under gravity. Nothing organized, nothing mature. That's the textbook version anyway. But this galaxy isn't some faint little smudge of baby stars. It's roughly 1,600 light years across and packs the mass of several 100 million suns. And when researchers used Webb's mid-infrared camera to dig deeper, they found something that really threw a wrench in things clear signs of oxygen. Oxygen doesn't just show up out of nowhere. It gets built inside stars and released when those stars die. So, finding oxygen this early means this galaxy already had multiple generations of massive stars live out their entire lives before we're even looking at it. Like, that's not a young galaxy. That's a galaxy with some mileage on it, like finding a fully renovated house where you expected an empty lot. A researcher named Valentino Gonzalez, who studies this stuff at a research center in Chile, put it about as plainly as you can. He said this galaxy is bigger and more evolved than anything we expected to find at that stage of the universe, and it's forcing scientists to ask whether these kinds of massive, mature galaxies formed way earlier than anybody thought, or whether we just got lucky and stumbled onto a rare one-off. And that's not just a small tweak to the theory books. Other researchers looking at similar galaxies found something else. Some of these early galaxies have up to 10 times more oxygen than current models predict is even possible that early on. That means star formation and the whole process of building up heavy elements happened faster and harder than any simulation currently accounts for. So, take a step back for a second. In the same stretch of sky, using the same telescope, scientists found a black hole disguising itself as a star, breaking every rule we had for how fast a black hole should be able to grow, and a galaxy that looks like it skipped its entire childhood and went straight to being fully grown, breaking every rule we had for how fast galaxies should mature. Neither one of these fits neatly into the models astronomers have spent decades building. And that's actually the exciting part. This isn't a case of, we were wrong about everything. It's more like buying a used car that runs way better than the mileage on the odometer suggests something doesn't add up. And now everybody wants to know why. And it's not just these two. Even closer to home, there's early research suggesting our own galactic neighbor, Andromeda, might be getting knocked around gravitationally by a smaller galaxy nearby, like a smaller guy throwing punches above his weight class. The universe, it turns out, doesn't play by the rules we assumed it did at any scale. Here's the bottom line. Every time we build a better telescope and point it further back in time, the universe keeps surprising us with things that grew faster, brighter, and stranger than our models said should be possible. And if that pattern's held true every single time Webb has looked deeper, you have to wonder what's waiting out past the current record. If this got you thinking, hit subscribe so you don't miss the next one. Drop a comment letting me know whether you think this is a once-in-a-billion fluke, or proof the whole early universe timeline needs a rewrite. And share this with someone you know who'd get a kick out of this too.